Okay, so day 2, we're going to do more of the BC with the parametric and vectors. And so here now it's giving me the set of how the particle is moving and all of the movement now with in parametric form, so with the parameter of t and with the time shown. So we have the more information of the flow, and it's awesome, basically. Okay, so first I want to look at this single equation. And this is going to be where the prior pre-calc comes in to remembering sine squared plus cosine squared of the t equals 1. So I'm going to go ahead and say, well, what would sine squared be? Well, sine t here is y over 2, so sine squared would be y squared over 4. Cosine squared, here I can see cosine would be x over 3, so cosine squared is x squared over 9. And all of that equals 1. So this is an ellipsis centered at 0, 0. On the x, we go out 3. And on the y, we go out 4. So it looks kind of like a football with the ellipse. Oh gosh, let's pretend. Oh, let's try that again. That was bad. Okay, I can do this. It's hard to draw with the tablet. Okay, so just make my dot bigger there. Okay, so here I can see this is what the equation looks like. And as I am plugging in with the time, it is moving in this direction. So it's kind of cool. You can also look at that in your calculators in parametric form. Go to parametric mode, and plug it in into x1 and y1, and you're going to see the same equation as this ellipse. Okay, so a little bit of the pre-calc just for fun here. So B, let's find the velocity and the acceleration vectors at time t. So first off, let's start with the position vector, and they call that position vector r, whatever. So I'm going to go and write it 3 cosine t, 2 sine t, so x comma y. So now if I want to get the velocity vector, all I do is take the derivative of this. So I take the derivative of each part. Then to get the acceleration vector, I take the derivative of that. And here I can kind of see, I can pull out the scalar of this negative and see that it is always opposite. The acceleration vector is always opposite of the position vector, which is what part B wanted us to show. Okay, so part C. It wants me to evaluate all of these now when I have pi over 6. So I'm going to go take this when t is pi over 6. So I'm going to use my pi over 6, kind of use my, oh, there we go, my right triangle, or my right angle here to look through. And at pi over 6, cosine is radical 3 over 2. So I have 3 times radical 3 over 2, and then sine is 1 over 2. So if you would like to simplify that, great. 3 radical 3 over 2 and 1. So my velocity here at pi over 6 is going to be negative 3 times sine of pi over 6, and then 2 times cosine of pi over 6. And feel free if you would like to rewrite that to make it prettier. And then what's nice is the acceleration. We have already shown that the acceleration is the opposite, so all I have to do is change the signs of what we had. Okay, part D, find the speed. So here the speed is the square root of my first derivative of pi over 6 squared plus my first derivative of the y part of pi over 6 squared. So if I want to find y prime of pi over 6, I basically did that here. So that would be the square root of the -3/2 squared plus, and I kind of already did this piece, the square root of 3 squared, which would give me, what, 9/4 plus 3, and if you want to simplify that more, awesome. Okay, part E. Here, I want to find where speed is a maximum, so I'm just going to maybe call this equation speed. And so the first derivative here was -3 sine t squared plus the first derivative of the y was the 2 cosine t squared. And now I'm going to find a maximum and then a minimum. So I need to find my first derivative. So I'm going to take my chain rule, 1/2, leave the inside alone. I'm going to rewrite that inside just for fun. So 9 sine squared t plus 4 cosine squared t to the -1/2 times the derivative of the inside. So this would become -6 sine t cosine t, and then plus 4 cosine t, and then negative sine t. So I went ahead and just left that. And now I want to know, where does that equal 0, or where does that equal d and e? So I'm going to go ahead and just rewrite this. This would be a -10. That's all right. Oh, shoot. Nope, 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 nope. Okay, hold on. These are a little off. This would have been 9 on the outside and 4 on the outside, right? Okay, yeah, duh. So this would have been an 18 and then a -2, 8. Okay, my bad. Okay, so now I have a -10 divided by that 2, which would give me 5 sine t cosine t over that square root of 9 sine squared t plus 4 cosine squared t. So to find where this function is 0, I set the numerator equal to 0. And to find where this is d and e, I set the denominator equal to 0. And then I go and solve. So over here, this could never be 0 if I'm squaring sine and cosine. I've put them all above, and I'm adding things together, and I'm multiplying by 4. They're never 0 simultaneously, so that couldn't happen. So when I'm looking for this guy to be 0, I'm saying, well, where is sine 0 and where is cosine 0? So I'm actually going to add in right here that we're only going to look from 0 to 2 pi. We're going to be checking a lot, okay? Let's just keep it on the interval of once around. So here I can see sine would be 0 when t is 0 and pi and 2 pi within here. And cosine would be 0 when sine is pi over 2 and 3 pi over 2. So now I'm going to go do my candidates test, use my t's, plug them into my speed. I have to do my endpoints, which are actually part of my critical numbers as well, and then the critical numbers. Go plug them in and go see which is the max. So I'm going to give you a second here. I just wanted to look up why I was doing that. I Knew it, I messed up. I went out 4 instead of 2. All worried about trying to make that curve. Let's try that one more time. Did you guys catch that as we were making it? Oh, silly me. On the y, it's 2. On the x is 3. You always want like the 2 squared and the 3 squared. Okay. That looks better. While you guys were finishing that. Hopefully you go fix that too. Okay, so now when you go plug these back into the speed, see if you got this. So here I can see that I have the max speed when t is pi over 2, 3 pi over 2, and I have the min speed when t is 0, pi, and 2 pi, which are actually going to be at these values when I have the max and the min. Okay. All right, let's go do the next one. Here's an AP example. So a particle is moving along its curve so that this is the position, and then they gave me this right here. So I know that x of 2 is 1 and y of 2 is 5. So I got that from knowing this. And then they gave me the derivatives, and they want me to find the speed of the particle at 4. So for the speed, I'm going to do that dx dt evaluated at 4 and square it, plus my dy dt evaluated at 4 and square it. So put that into your calculator, and you can pause me if you need to. See if you get this out. Make sure you can put it in the calculator. Don't just write what I write and be like, oh, I'll figure it out later. Go make sure you can type it in. That way, if you can't, you can ask me. Okay, B wants the acceleration vector. So now I'm going to take the second derivative at 4 and the second derivative, right, t at 4, and write it as a vector. So y'all, I am definitely like, well, I love to take derivatives and see how pretty and everything they are. I am definitely going to be using the Math 8 here. Okay, this is a calculator question. So I'm going to go to Math 8 and plug in 4 here and just see that this is negative 0.041, and do the same thing here and get 0.989. So again, if you need to pause, make sure you can go get those two things. These are really calculator active questions that we want to utilize our calculator. Okay, next one wants to know, so they give me some information. There's my dx, there's my dy, and they want to know when is speed 10. So this one's a little bit different. I'm going to set up my speed, and instead of plugging in 10, I want to know where does it equal 10. And so all I ever do, you guys, when I'm trying to find equations that are equal, is I bring one side over and find the 0. And I know I'm only looking at my window greater than 0, and this is giving me a hint. I'm not going to look much past 10, so I'm going to look here and go from -1 to 1, since I'm only looking for the 0. Go graph it, pause if you need to, find your 0, and make sure you get the same thing. B. Okay. Got a lot of fun stuff to do. You can try this on your own. See if you get A. Also want you to try this one on your own. Pause and take the time you need. See if you get C. And the last one, I want you to go ahead and try on your own again. And see if you get B. Okay, I would like to do this one together in class to make sure that we are super good. Okay. And I want you to try these two on your own. Then after that, page 2. So I want you to try these next 4 multiple choice on your own. And then after that, we're going to do the other 2 free responses together, 3 in class. So if you want to pause me and then come back and check that you get B, C, C, and B. Okay, so if you've got that, that is great. I would like to do the rest of these questions in class together. All right, hopefully I didn't mess you up too bad with that ellipse. But besides that, all of these are going to be super fun. And next up, logistic.